Hello, welcome all. My name is Suman from Uplatz. So the module we are discussing about statistics and EDA. So in this module, we have been gone through various kind of techniques in a descriptive statistics. We understand about very basics along with variables, type of variables and their scaling and then information. So I'll just recap the shape in it that we have been gone through these things. So like array quantiles or quartiles, we can call as any them. So these quartiles will explain the data or numerical data, how they are distributed. For example, in these cases, we can say evenly distributed. Why? Because if you see the numbers 1, 3, 5, 8, 9, so the lowest is 1, highest is 10. 10. But the value which is saying, the value which is saying, 3, 5, 8 is different compared with 4, 5, 6. So you can see, this is a simple example. 358 is different compared with like 456. And what we understand? And a 456 very near, you can see. Of course, this is very small, but for example, we can say 356 might be two changes here, we can see, and here might be three changes. So that is why it is evenly distributed. Means what? The data will be look like, like this. The chart will be look like, this value. Second thing, in the same way, 456. So the data will be look like this value same way, but it will be close move to towards near like this. That's this is called 4, 5, 6. Now what is skewed left? Okay. The skewed left indicates if you look at here 1, 2, 3, and it's going into like this. We can say these are very less, but going forward these are more values. Okay. Now skewed to the right. So skewed to the right indicate these are more values. And coming back to here, the tail is here. So the tail will be, here, and that's why these are called 6, 7, 9, and these are called 1, 2, 3, 3, 7, something like that. Okay, less value. Okay, so skew to the left and skew to the right. So it's going towards the most of the values. So that is general assumption. But in me to say, we can say that's what general assumption. Like these are just four numbers across what? Across maybe 100, across maybe 1,000, across maybe lakh. Okay, or you can take crores. Take it as a simple example, like ages of the people in India, 140 crores are there. That is also you can make it as a quarters because those are numbers. But ultimately, you have to know, whether the ages are because we know it as a human or like ages, we know it mostly. It was started with 0 and mostly 100 or 120. That's maximum. So what we understand, for example, if we got evenly distributed, what happened? See, few people are okay, they are very young age, before 30 or below 25. But most of the people are in between 25, 30 to something like, 60, 70. And very least people are there now currently, I mean, this year, or you can take maybe following year. So three people are there. That is what evenly distributed. But what is most value is closer to the center. Like center is we know it a 50 years center. Let's understand 50 years, 50 or 60. Now most of the people in the sense like 40 to 50 or 50 to 60 or 70, and those people are more compared with rest of the people like either senior citizens or either might be kids or young age or adults. These are very less. What is skewed to the left? Skewed to the left indicate what? Most of the people are above age, above average age, or we can say more count will be goes forward towards the 100, towards the 70s, towards the 80, 90, like that. Skew to the right indicate that one, skew to the right. So skew to the right indicate the tail is the right side. So most of the people are in young age. So that's what 124 of people. It's a simply telling of four numbers. Okay. So that's what data. That's what statistics. Now coming back to is that only example? Say similar example here I explain. Box plot is there. So either you can take same box plot, it will give here. So it's not the same thing. So in this case, first quartile is there. First quartile is this value. You can see. So first quartile is this value. Okay. So this is also called second fifth, so 25th percentile. Second quartile is this value, median. And this is also called second quartile or median. And the third quartile indicates this value, and this also called as 75th percentile. Now what is minimum is? Minimum is this value total, and this is the minimum value. This comes to here, and this is the maximum value, so which comes to here. Okay. Now think in that way. Think in that style. Okay. So now coming back into here graph, it will explain couple of this. Okay. So the things it explains, for example, take it as a similar way concept like this you can start 0 or 1 year and go to something like 100. Now what we understand from this data. I'm taking for example 0 years and this is might be, let's consider the 120 years. Maybe. So so the people are mostly in between, like maybe in between, let's take it as a 50 here. So 50 something here. So median is not mean. Okay. So median is the center of the data. So for center of data, you can take here. Now the question comes to here, it will explain plenty of things. For example, what is potential outage? For example, in these cases, 0 to some years, like 15 years, very few people are there. Okay? And most of the people started with 30 or something, 30, 35, and goes on like this. Okay. And similarly, we do have some 60, 70 people are there. But 100 plus something, very few people are there. 100 plus maybe 112 or maybe 110 or something like this. So very few. So these are outliers. In this cases, these are outliers. In this cases, these are lower outliers. These are upper outliers. Okay. So why? Because they are not nearby, standard these values. So that is the mechanism follows. Okay. That's the mechanism general follows. Now how to decide? So that's where they are giving minimum value in the quartile minus 1.5 times IQR. So first you have to understand quartile 3 and quartile 1. Then you have to deduct. So that name is that IQR. That name if you calculate 1.5 times. So that is a statistical formula. That's research formula. It's not why should we calculate multiply 1.5. Why can't we multiply 7.5? See, that is from research. Okay, uh, came from the plenty of statistics which work for the decade or maybe centuries. Okay, so that is the formula we are following, and so the question comes to here: Q1 minus 1.5 times square is this value, and Q3 means this value. Q3 plus 1.5 times IQR this value. Now out of this, if the values are maximum value, okay, these are more than this value. So these values are like we can say outliers. Okay. So in these cases, these values. Okay. So now comes to here is you can take in the similar concepts and we can able to understand how these outliers are shaped. Now I mean the same way I have been explained skewness and kurtosis. This is also same thing, but as a graphically, as a numerically, it will explain couple of things. Now, whatever I draw it, same thing I have make it as a chart here, that attachment and like a diagram. So in these cases, we can say positive. Means what? If your skewness, if what skewness starts or skewness numbers are positive, then we can understand, okay, the tail might be right side. Okay. Now, if your skewness negative, the tail goes to left side. And if your skewness zero or nearby zero, even though you can consider statistics in that way. It's not exactly. It's not this fixed. Statistics we have to assumption and according to the data. That's what statistics entirely. Now nearby zero or zero we can consider okay. These are distributed like this. The same works for the kurtosis. So in the kurtosis perspective, we can say uh, height besides how flat it is and how width it is. So that expects values of kurtosis. So in this case, generally we can assume like three. So that's also research kind of thing, and you have to know it. Now the question comes to here is we have to understand. So when to use mean, when to use median, when to use mode. That's important. Even though we learn mean, median, mode, but can we use every value for mean, median, mode? So the answer is no. Of course we can use it, but the problem is assumption like insights or patterns and those things find out is important. That's what AI feels totally. Nominal. Your data is nominal. What I have to look at? So I have to look at mode. Okay. For example, what is your favorite color? If I ask a couple of participants, they randomly can take 50 people. Now, what is favorite color? They might say like a violet color. Now, violet color, they are telling people, couple of people. But when you compare with other people, they are telling blue. They are telling other person red, other person green, other person yellow or purple. Now, most of the people tell they are violet. That's what we can say. Okay, this is what me mode. Okay. In this also bimodal is there, but let's make sure to figure out only just repeatable duplicated and most people which they are saying. Okay, or we can say in that way. Take it a similar other example, real life example. If I want to tell, like some surveys we are getting regularly, right? So surveys they are giving like, can you able to judge whatever public offering, like maybe it might be some policy release, some rivers or some bridges are constructed. So how can you think that this bridge works will works for the a couple of the people, okay, or something like not only bridge, like take it as the education level. So how we can think like education level is then in 2020 I think India has been changed their previous old level education, so which changed into new education standards. Okay, with across the total like high school standard too and total PG and PhD standard they have been changed. New educational kind of things is there. Why they have been changed? Because that is what we have to understand. Because if you go to 50 years back, 40 years back, education is not like right now. Because we know it digital is there, we know it as something which has been changed. So if you ask them A plus B, they can understand that is needed. But in most cases, they have to understand other perspective, fast environment, but not a speed, a slow kind of thing, like whatever we learn early. So that is what a simple mechanism, but we have to know it, that value. So which indicate something kind of mean, median, mode. Okay. So ordinal is there. When you have your data is ordinal, in that way, in that cases, I have to go what median. Okay. So why? Because ordinal is there. For example, rating is there something. Uh, for example, a movie released or something. 5 rating. What you tell rating. Okay. So somebody might tell 4. Somebody might tell you 5 out of 5. Somebody might be tell 1. But ultimately, median is, if you want to look at the center, so we have to look for the median because the order is there. Okay. So for orders, I have to look at the median. So that makes sense. For example, some people are telling, 3.5. Most of the people are telling 3.5 or 3.7 or something. Then I would consider see, movie is better. We can watch. one time or something. Okay. But most of the people are telling median is going through, something like a 2 or something. In that cases, we have to understand, okay, this might be either watch or not. That's optional. Okay. Now this is about ordinal. That is about nominal. When it comes to ratio or interval and numerical, in that cases, I have to look at the skewness. Okay. Mean and median. If the skewness is not skewness, you have to look for the mean. If some skewness is there, you have to look for the median. Okay. So, so that is the mechanism it follows. And a similar way I explain here with the symbolic notation like statistical Roman symbols. So these are Roman kind of symbols, and these are general we can able to look at and explain in the lessons or something. So this is what skewness, kurtosis, and mean, median, mode, and variance. Now these are theoretical, but when it comes to practical, when I want to understand these things, so what I have to do? So the first thing already we know mean, median, mode, and SD variance. Those are standard functions are there. You can directly apply on top of it. But when you want to go to skewness, kurtosis, and separate is one thing. Instead of separate, you can go ahead with more further with packages. So that will use more information side by. So that is the advantage. So that is the reason we imported here, and we'll just ask it here after loading library, and I'm asking skewness on top of data, and I'm asking kurtosis. This comes from the not direct function. This comes according to packages from the package. So we got negative. So I have to look at what is negative indicate. So like I explained here, negative skewness indicate here in the graph it's clearly indicate. So this towards goes to right. Okay. Now that's what. And kurtosis. So it's a 2.3. So 2.3 in the sense like it's nearby 3, right? So 2.3 is less than, but slightly here, slightly like this value. So slightly in the sense like it's a just like assumption or maybe observation. In that way we can consider. But it look like a small plateau kind of thing. Now what we can understand from the data simply, I can say skewness might be this and kurtosis might be this. Okay. For that data maybe time data. I have taken some time or something, but you can take another data like any random numbers, then I can make sure to understand these values make sense for the understanding similar concept. So for that is the reason I gave it here one table. So that's available here in your attachment here, a data folder. So I'm just reading that CSV file, and I can question here. This is about Titanic data, ship data. So which I explained. This is a real world data, one thing is, but this plenty of people are using, okay, lakhs, maybe crores of people are using who are in this field. So we can just consider the same way. We can ask for mean, mode, and table, something like that, and median. We'll get all this information. Okay. So that's what similar way standard deviation and variance, and we will get all those steps. Now, if you want to make box plot, just give it a box plot, and we have to give it a numerical variable versus categorical variable. Okay. So this this pipe operator we have to give till operator so that it can able to understand and it can figure out whatever the content. Now, instead of if you want to go with a box plot, can I take other some other data as well? The answer is yes. Maybe you can take some XYZ ABC data frame. Now here you can take some numerical data, and here you can take same XYZ, and here you can take categorical data, and you can give it label like this X label, okay, whatever way, and Y label. So X label, Y label optional in the sense like to know it, and the color you can give it red or something, whatever color we want to go ahead. In these cases, I give it red, but in your cases, whatever we can give it, we will get it. That's one thing. And that 5 number summary is also there. So it will provide 5 number summaries. So that's also, make sure to explain. But whatever categorical data, it won't provide the 5 number summary because it has to be looked for the, minimum value and maximum value across total. And it's also look for the, what is the, first quartile and third quartile. So for categorical data, it won't works. Okay. So that is the reason for earlier I have been told for categorical data, either nominal or ordinal. So we have to look for the what? Either nominal, if it is nominal, we have to look for the mode. But if you look at here, there is no mode is there. If it is ordinal, like we have to look for the median. But is that ordinal? We have to mention. Ordinal is indicate here. Either we have to go for factor or something, or we have to mention. So that is the reason. It's not it's a total nominal. So total nominal. So that is the reason it's won't works. But if you rest of the things, if you take it, it can make sure to understand. These are the list of the packages we can to describe the data. Okay. For example, this site package is there, HMIS is there, PostX is there. So many similar packages. So these values also utilized for the descriptive statistics along with all this information. Now you can see same data, Titanic data I have been asked, but what we got it is important. So what we got it here, these columns we got it here. These are all columns. Left side, if you look at, those are column names. Okay, those are column names, and it explains. But what? Sorry, those are rows labels. You can say rows label. Though column names becomes rows labels. But what columns we got it? Columns, or we can take. So these are measurements. What R is giving for us. Okay? This is just column names. And what these indicate. That's what measures of this value. Okay. Let's say, for example, we can take simple example. So ages are there, 891, 740, 714 ages is there. If you calculate their mean, you will get this value. Only age, only one column, which I'm telling. But sex is there. Sex is nothing but male or female. But do we get any mean? Answer is no. Okay. So we won't get it for me. So that is the reason we are not getting here. So that is, like categorical data, we won't get it, but numerical data, we will get it here. But it will give not only one column, it gives all the columns, all the digits. For example, any indicate, where indicate variables, like which column it is presented. Any indicate how many are there without missing values. Okay. Means 714 age here indicate remaining or missing values. Remaining as blanks. Remaining are blanks, we can say. But it's calculating, maximum. For example, you can take age. We got 8.0, 80.0. So that is the maximum age across 714 people. Okay. But total 891 rows are there. Okay. Now this information gives plenty of things, right? One column, it's explain statistical data across total, and it's also calculating other statistical information like mean, standard deviations, and minimum value and maximum value. Now it comes to minimum value, like I explained, 0.42. So we can consider as a 4 month boy or girl, we don't know, but it might be error something they are mistake because it's they are taking raw data. But ultimately, you have to know it. That's what. So 8 is the maximum age we can say, and so that is what we have to understand here. And this range indicate low highest minus first. We can say simply highest minus first, and that's about total. And similar way we can work on different packages, and we can able to understand here clear information. Now question comes to here is okay, this is fine for descriptive statistics, but if I want to go ahead with inferential statistics, what I have to go ahead. Okay, so that's the mechanism it follows. So for inferential statistics, what I want to give it a simple example. like what concepts we have to focus on mostly. We have to focus on the sampling of one thing. In the similar way, we have to provide, we have to understand by taking sample what is the goal of of going to inferential. That's a different and compared with the descriptive statistics. Descriptive statistics is nothing but we are looking the data and we are finding the values and we are describing the data. Whereas inferential statistics is nothing but simply we are going with the data and we can able to take sample from the population, but we want to calculate based on the sample we have to calculate the population. So for that there are two mechanisms are there. One is estimation is there. Second thing is like distribution is there, and other thing is testing is also there. Okay, these are the two mechanisms which we have to focus on. Okay. Now comes to here is point estimation is there. Before point estimation, I'll go use as the simple sampling and sampling distribution. So what is sampling? In the case of sampling, we can understand sampling indicate like we are taking a value, a couple of values from the uh, group of people across total population. Suppose you can consider as a average income of people which are there in Hyderabad, something. Now, what I'm asking, average income of people in Hyderabad means what? The Hyderabad people maybe right now 1.5 crore is there or something. Okay, 1.5 crore or something, or 1.2 working people. Maybe you can take any day, any working. Maybe you can take a simple person like who is working on teacher or who is working as just like IT person or who is working in government sector or private sector. But across total, what is the average? What is the average income? So what it explains? It explains couple of information like average income in the Hyderabad. We are asking now how do I get it? What sort of things I have to do it? Okay. So for that, what I have to do it here, I have to take simply there is package called dplyr. So I want to go to here dplyr. So this is the package. So this is mean to for data manipulations. Okay. So this to learn about dplyr. So start with the vignettes. So they are giving vignettes. So you can see browse vignettes package is equal to dplyr. Okay. So that is also there here. Or you just type it maybe F1. Now also you can get it here. So you can see this is a dplyr which is there in this directly is there in my computer in this path. In your computer, maybe your computer name, and in the similar way here. Now question click on here. Now you can able to see. So you can able to see that value in the dplyr sense of here. So now you can see it's giving a documentation. What is provided? One is a dplyr. Second thing is the title, a grammar of data manipulations. To learn more about dplyr, start with browse vignettes and dplyr. Let's try it here. So browse vignette I am taking and just want to copy paste here. Let's try it here. I'm loading. Now you can see it gives us couple of information in the here. So column wise operations. If you want to do column wise operations, you can click on here and group data or introduction to dplyr, programming with dplyr, row wise operations, two table verbs using dplyr in package, window functions. Okay. So these are the information they are providing in the browse vignette function. So let's go to introduction. We'll try to understand. So this is about introduction simple, right? So what it's giving? When working with the dplyr, like when we're working with the data, so we have to figure out what you want to do first and describe those tasks in the form of computer program and execute the program. The dplyr package makes these steps fast and easy. So by constructing your options, it helps you think about data manipulation challenges, and it also provides simple verbs, okay, or functions. So that corresponds to the most common data manipulation stuff. So it uses efficient backends, and this document introduces dplyr basic set of tools, okay, and shows how we can apply these kind of thing on top of the data frames. Okay, so that's why it's giving these information. For example, what is Star Wars? Okay, so what is Star Wars? Can I go to we'll go to here our studio and we'll make sure to understand here. I'll just go to here and type Star Wars. You can see. Okay, but Star Wars I'm taking, but is that Star Wars directly available in data? So the answer is no. This is available only in the dplyr package. So once you load it only, you will get it. Okay. So what it's giving? It's giving simple information like name, height of the person, mask, hair color, skin color, and go sound like that. So just click on here simply Star Wars, and it's giving help. And click on here. Now this is the data. Okay. You want to know simply how many rows, how many columns, just give it as a dim. Okay. So that it will provide how many rows are there. 87 rows are there. 14 columns are there. So if you want to look at these Star Wars similar way, so you can just review it so that you can see visually in the topmost. So I can able to see here name of the person and person height and person mass, weight, color, hair color, skin color, and eye color, birth year, sex, gender, and home world, means location and species. Okay, and something like fields. These are the information, vehicles and starships. So these are various information which provides here. So some of the persons like humans are there. So some different Star Wars is kind of I think game or something. But we can see here these values. Okay. So how to get it? For example, single table verbs I want to get it. What is they are giving? They are giving first row wise. Okay. So first they are giving row wise, and what we understand here. So this single table verbs you can see dplyr aims to provide functions for each basic verb for manipulations. So these verbs can be organized into three categories. Okay. So based on the component. For example, you can filter, chooses rows based on column values. A slice, chooses rows based on location. Arrange, changes the order of the rows for column values. Select, changes whether or not a column included. Or rename, you can change the column, rename, and you can also mutate, means the columns if you want to create new column, and if you want to relocate order of the columns, and you can also look at summarize the data. Now next one is the pipe operator. So pipe operator is this pipe operator. Okay. So this pipe operator is generally indicate what value it will be, goes one by one. Okay. It will goes in the sense of like we can make sure to understand. Pipe operator is nothing but sequentially it will go ahead, it will move ahead, and it can able to figure out that value and provide that kind of constructs. Okay. Now let's go back here and we'll make sure to understand. So what concept we have to look at further. So first we have to understand the data first. Okay. Then we have to understand you know the data and along with row wise and column wise. Okay, so that we can see uh, we can see what we want to look at any operations. So any operations like filter and something like select some columns. So we can go ahead and understand it so that we can able to see it that value so that we can able to understand here how this works on something like this. Okay. So first values of control shift n, I think we have to use it. I'll just type it here or just go to here, pipe operator, of course. Control shift. Now this is shortcut for pipe operator. So to get to pipe operator, my suggestion is you can press Control plus Shift plus M. I mean stop. Okay, this is the pipe operator. Of course, it will give error because it's not an comment. So let's make it comment here. Make it comment. Now I'll explain a couple of examples so that you might understand. So I'll just go to here, introduction, and we'll make sure to understand, what they are giving. Now filter you can take simple. Now what is filter is giving? For example, if you look at here, Star Wars we are typing, pipe operator we are typing, or just bring it here. You can see Star Wars is the data, pipe operator we are using, and we are filtering what skin color only one column double equal to light and eye color double equal to brown. Okay. So what is filter? Filter is according to rows. Okay. According to rows of what? So first this pipe operator works like this. So whatever this value is, first you can take data frame. Second value, whatever your operation, third thing. Okay. Whatever you are getting third operation, so that make it a result that make it pipe to third operation. For example, same pipe if you use it here, now we'll get input of this value. Okay, not this value, this root operator. Now make it one more pipe. We'll get result will be pipe put here. This result will be pipe put here. This result will be pipe put here, and this result will be pipe put to here. So like that moves here. Okay, so that is nothing but sequentially one by one it works. Okay, so what I want to do it here simply, I just want to copy here simply. I just want to copy, and I want to go to here my this value. I will just move down here. Now you can see what we are doing here. First time we have taken Star Wars data and I'm filtering what skin color. If you look at here, skin color is there now. Skin color. Okay. We are filtering skin color only light. Okay. So let's look at here light so that we can make sure to understand. Just go forward here. You can see this person is light. So his skin color is light. Correct? Now eye color is there. There is another column we are taking. Eye color is brown. Okay. So brown is there. For example, this person is also brown. Okay. Now such people are how many? So just forward it and just run it. So okay, what we got it the output here we can see we got just 7 only. Okay, 7 versus 14. Now early what we understand dim. Let's type it here dim of something like Star Wars, and I'll getting 8740 now. So out of 87, only 7 people are there whose hair color is brown. Okay, and similar way, whose either eye color is sorry, skin color and eye color is brown. Okay, so you can see here clearly indicate here this box indicate what So these light brown, light brown, and light brown, light brown, light brown. And these people are just how many people? Those people are seven only. So it's a giving table, and it indicates seven people across total 14, total. Now you understand how we can make a filter. Now take it any example, such example. So we are making, for example, this is roughly equivalent to base R code. What is given? They are also giving base R code so that you can try to understand. So same data frame is there now. Should I write like this? The answer is yes. So I have to take Star Wars. I have to give Star Wars, and I have to give dollar symbol, column name, and double equal to light, and symbol I have to use it. And Star Wars again I have to write. Dollar symbol I color I have to write. Double equal to brown I have to write. Okay. So all this length of the things this can done. Because when you type Star Wars, it can understand. No need to give dollar symbol again. It can easily understand. Okay, this skill color indicate according to Star Wars data frame. But in the here, it's clearly we have to type couple of times. Three times we have been typed same thing. So that is avoided here. Okay. Second thing, we don't know what we have to do. For example, here filter means even normal person can understand. For example, a person who is not computer programmer, he can even understand. Okay, filter is nothing but filtering. Okay, but in these cases you have to know the code, base or code. Okay, and here we have to give the AND operator. So this is somewhat complex, somewhat even we know it a base or, but somewhat a complexity. So that's where make into dplyr. So it will make it into easy for us to make sure. Now same way, similar way you can take Star Wars, but I'm arranging height versus mass, height comma mass. Okay. So what is going here? So if I go to if I able to understand here, so I'm giving simply one example. Star Wars, I'm arranging height versus mass. Now when I get it here, so what happened here? Height we got 66 and weight mass we got 70. So that is the lowest. Okay. And 79 and we got 15. And 88 we got that value. So this indicate it's arranging a couple of values. So according to those values which are arranging. Now the question comes to here is use descending also. You can also use the descending order. For example, this is a very simple example we can see. But clearly it indicate what? It indicate a value which we are descending from the height. Now what is the highest height which is in the 87 people? 264, highest height. And what is the next height? 234, 229, and goes on like this. So you'll get last value which indicate lowest, very lowest height. Or if you want to make ascending also you can do it. So that you are getting into ascending. Oh, ascending, okay. Yeah, great. Okay. For arrange, right? So arrange only we are looking. I think that by default here, let's try it without height, without this thing, you can provide. Yes. So they didn't provide anything separate. So it's already by default there. So if you want to make descending, you can give it another function called descending. So 66 is the very lowest height. You can see it's clearly indicated, and 79 and goes on like that. Okay. So that is the main mechanism we have to understand how these values are working, so that we can able to understand now how this information will be provided here. For example, empty cars is there. That's okay. We understood, right? Hmm. Let's take it empty cars here simply, and similar way control shift 10. I'm taking filter I'm using, and here I want to use cylinder, right? Cylinder equal to double equal to 6 something, double equal to 6. I'm taking. Now we got 6. Okay. On top of these data, you can, for example, cylinder you are taking, that's fine. And if you want to look at here, 543 is there here, and okay, card is there, 4146. Okay. Now, so after this, can I filter one more control shift I'm asking, and in these cases, I'm asking filter, and here I'm typing carb equal to something like 2 is there, na here, 2. Shall I use 2? The answer is just right, 2. So what happened here? So there is no row presented. Why? Because this is works on top of the this result, this total result. Means for this, after this pipe, first is this pipe, right? So this pipe, this is the input. Now what do you want to do it with that? Now for this, pipe, so the entire result of this value is output, input. So that is the reason we are not getting. Now, let's write here whatever 4 is there. No? So 4 you can type or 1 you can type. So if you type it 1, because that is there in the sub data, so that you will get it 2. You can see. So that is what pipe. So pipe is nothing but, so the value which left side is input, and whatever the left side is till next last no, that value. So that is the input for that. Now, so we got only these the sub small data, right? So now we can arrange after that. So for example, I want to arrange dot something. So control shift I am giving M, and I want to arrange I am giving, and in the arrange I am giving something like dot, arrange I am dot. So what is the small differences? See, so if you look at arrange, arrange is the next pipe operator. For this, the entire result is this set. This entire set is the input for that. Okay, so that is the reason I am arranging. So dot, we are arranging dot, right? So it will go to this column called dot. Okay, since it comes into 3 first and 3.08 first, 2.76 later. But if you look at here, after arranging, we got to 2.76 first, 3.78 last, because we are arranging in ascending order, like whatever we earlier used for Star Wars, similar concept. So that if you understand that concept, then you can make sure to understand how we can work for the data manipulations on top of the dplyr. Okay. So dplyr is nothing but pipe operator. First thing, pipe operator indicates left side is input for you, the right side of the pipe operator. If you type it multiple pipes, multiple types. So it's nothing but whatever the result, the overall total left side of the right side of the last pipe, that entire left side total is the output should be to the input to the next value that pipe. Okay, so that is the mechanism it follows. Okay, so once you understand this pipe and operations, then you can make sure to understand how these things will works for the rest of the things. Okay, so here arranging we understand in a similar way. Choose rows using their position. What is slice? slice, you have to choose rows with something. For example, slice lets you index rows by their integer location. It allows you to select, remove, and duplicate rows. So we can get characters from row numbers 5 through 10. Okay. For example, you can take Star Wars simple. Star Wars I'm taking simple, and I'm just giving first Star Wars this data. Okay. And what this person is doing here, what this document is saying, slice 5 to 10 we are typing, right? So just copy it here and just do it in our studio. What we get it here, slice 5 to 10 I'm asking. What happened? Let's see. Now what we got it here, if you observe here, so if you observe here, so what are the fifth person, this person, and till 10th person. So that is only we got it here, we can see. So this fifth person, sorry, this fifth person is the first. Means it value, this value, it's omitted these things. These things are omitted. These things are omitted. Okay? So that is what slice. Slice indicate what? You can give the row number something to row number something. I have to provide that value. Okay. So that is what operations which goes in. So this is also similar in base or also you can do it. But more than that one, package is working on couple of things. Okay. Slice head, slice tail is also there. That is also possible. You can utilize, even filter it. Okay. Slice head, slice, or something like, tail. Now, when I give it, a slice head here, what happened? We can give the internal number rather than, like, rather than something number to something. So you can give it here, okay, 3. Now, if you go to Star Wars, okay, so it simply gives, first to 3 only. We got it here. First to 3 only we got it, but rest of the things we are not getting. Okay, so that is the mechanism it follows generally, and the slice sample is also there. Sample is sample, like how many you need, how many values you want to go ahead and randomly sample, and we get that is also there. So I just type it here. So this is a random values. Okay, means if I look at Star Wars only, so if I look at Star Wars only, and you won't get values, but I mean you are getting whatever the data frame which already there. Okay, but in slice sample n is equal to 5, somewhere it will look maybe chat Pisco is somewhere some location out of 87, right? Okay, so that's a mechanism it follows. Okay, so we have to understand first how to filter and how to make you sure to provide like slicing, and these are all things. So once you know it, pipe operator, once you know it, how to select and how to get into understand, then we can practice in the next concept about what is the general mechanism it follows. Okay. Now what we'll do, just take it a similar example, and what I want to create here simply for our sake of data. So I mean to explain that context I have been taken, so that you might understand. Okay, this is what we can able to do, right? Now, take it that context, and I want to create one kind of things like sampling. So for sampling only, I want to explain all these terms. Okay. So for hypothetical distribution, we can take it so that we can make sure to understand for simply sampling distribution, so that we can make sure to understand. Like I explained earlier, if you remember, some age of the age, not sorry, income in some year something. Okay. Now if I want to look at here, what I have to do it first, I have to type it simply. Dplyr already loaded now. So first thing is I just type it again, library, and dplyr I'm typing. This is first value, and just shift enter in the console, so that it will be stay there. shift enter, marker, cursor. Now next option is have to create something like generate some. So in this case, what I want to generate here, generate some hypothetical population data. Sorry, population data, that should be income in rupees, Indian rupees. I'm just typing. Now shift enter. So here what I want to give first, set dot seed. What is set dot seed? Set dot seed indicate like whatever I'm typing will get same random values there. Okay. Let's take it as 1 to 10 people, 1 to 10 numbers are there. So can you pick up, if I ask one person, can you pick up 3? He might pick up any 3. Maybe 9 he can pick up because I'm giving 10. 9 he might pick up, and 5 he might pick up, and 6 he might be pick up. Okay. Now second time if the person is other person, for example, he is asking, can you tell me what is the, you are picking, okay, 5, 3 or maybe 7. Can you tell me what is the maximum, or can you tell me add it? What is 5, 3, 7? Obviously 15, right? Out of 10, I'm giving a person to pick up 3. Okay. Out of 10, he is might pick 5, 7, 3. So only one value. Let's me ask, 573 and 573 indicate 50. Now other person if I ask, or maybe same person tomorrow if he come it, okay, and he might change it. He might ask again. He might pick up other 3 because 1 to 10 there are plenty of numbers are there. So he might pick up 9. He might pick up 5. He might pick up or something like 2. Now if he add it, what he will get? He will get different number because here 537, but there some 2 and some other number. But whatever early person who is pick up 573, that value if you want to get it other person as well, then we have to go give set dot seed and some number. Okay, that number again you can type, then you will get the same number. Okay, so that is the mechanism. Like sample is there providing. Sampling is nothing but any value we can pick up post value randomly. But while picking randomly, if you want to get that random again and again same set, then we have to give set dot set some number, some unique number. So with that number, if you run it again and again, you'll get same number, same sample values. So that is the mechanism, it follows. So even not only Python, in our languages also we do have, right? So that's we have to use like similar concept, and we have to use it their concept. Okay, but here we have to np dot cd is there, something like in a random np dot random values we are getting numpy or something. That is the mechanism it follows, similar concept, but we have to provide what value we want to take. Now that's okay. We are going to be taking we are going to generate first. Now in this case, what I want to provide here, I want to give it population simple. So population, I want to provide here simple one population. Let's say population. Okay, I'm taking population, and in this population, what I want to take it simply data dot frame, because we know it's a data dot frame, and in this data dot frame, I want to give it some column called income column, and here income column I want to create random normal distribution. R normal random normal distribution. Here I want to take it something like 10,000. Okay, and here I want to give it something like mean. Mean indicate like 50,000. Okay, 50,000. Okay, and SD indicate standard deviation indicate. So we have to give standard deviation. and I have to provide 15,000 something, 15,000, right? Now, I'm taking simply a random normal distribution from the 10,000 values, and can you pick up with mean and standard deviation this value. So that is what population which we are storing. Okay. Now, this is only population. Now take a random from this value. Take a random. Okay. Take a random sample of, let's say, sample of 100 individuals. Okay. And question. Now population is, if you look at population here, so we'll get it here data frame. But if you look at population, so you can see these many. Okay. So these many people are still 9,000 omitted, but still we can see these are 9,000 plus 3,000, 10,000 people. Their salary which I generated, their salary, these are all income. Okay. Or we can take population. Okay. And already I just make it here. Control Shift M and slice. Head is there, no? Slice head. I just want to give it maybe 5 people. Okay, slice head, right? Slice head only. You have to give n, I think. Slice sample, we can give it n equal to. So we have to give n variable, we have to give it. Now you can see 5 people income I am getting. Okay. This is a 5 people income. Of course, early we have been written right only, but some values we have to provide with the argument n equal to 5 so that it can understand. Now 1 to 5 people, their income I am provided. Some person, first person 41,592 income, second person 46,547, third person 73,000 something like. Okay. So this is total population, but this is total population. But I just want to create a sample and I just want to take out some sample data so that I can make sure to understand here. So for this, I just want to get a sample underscore data and I want to give it here. And I want to provide simply sample in sample underscore n, sample underscore n. So this is a function which will take population, okay, and you can ask any people. For example, I want to take 100 people out of total population, and now you can calculate their mean and their average. Okay, so their mean and their average. Now we can look at here, just take it as this mean and this average. So for example, let's say sample I am taking and mean I am typing, and here I am asking what is my I am asking mean, I am asking mean of what, this value, mean of sample underscore data. Okay. And similarly I am questioning sample underscore standard deviation, let's say. You can take similar manner, but you have to take it SD, standard deviations. SD indicates standard deviations, and here we know it SD already. And same sample, I want to take it data, not data, data only, sample data. Now I want to print it here, those both. Okay, so I have to print, maybe I have to print both values, print, and I have to take it as sample mean, this value, and shift, and I have to print. Then after I have to take it simply sample SD. Okay, that is what sampling. Okay, so that mechanism is generally indicate a sampling. So what we have done here, simply sampling, taking, and I just want to filter. Okay. Is an object cannot be coerced with the double. Okay. Yes. Okay. So here we have to take one step forward because sample data is not like one value. It contains two columns. You see. So that is the reason you are not getting. So only change here sample data dollar symbol income and sample data dollar symbol income. Now this time we will put what we got it here 49,640 and 13,850. But if you look at here while creating my data, so what I have give it here, so you can see this value which I give it. So mean is 50,000 which I give it, standard deviation 15,000 I give it. So if you look at here, so whatever sample we are getting nearby 50,000. Here we can see standard deviation is also nearby 50,000. Maybe some changes are there, but that is what we can make sure to understand. Okay. Out of 1,000 people, a person is picking just 100 people randomly. Okay. But that random will be generate and it will explain this information. Okay. So that is what sampling mechanism. Okay. Now you can try in other way as well. For example, next time if you try it, so just go ahead here, similar concept in the same mechanism, and you can find out this value, this value again. So this time it's not the same sample because I'm not using seed. I'm using only samples are seed. I'm using only for the population, but not for the sample. Now this time you will get different income. I can see this time you will get different income. This time you will get different income, different ST. This time you will get different income and different ST. But if you look at whatever we created across total, whatever we are giving something like values which mean and whatever we are doing, this is sample data which I given z.c to know it. Okay. That's what population total. But across total population, what we are picking a few people total information, and that can we can make sure to understand 10,000 rows, 9,000 plus 1, right? 10,000, not 1,000. 10,000 people data we are taking, 10,000 people population we are taking. For example, Hyderabad people 10,000. Let's assume in that context. Now I'm picking up sample. Now that sample will explain 49,000, 47,000 something. Then I can make sure to understand, okay, this might be 46 to something, 40, 55 or something average. Okay. Because 10,000 there, you are picking just 100. Okay. 10,000 there and we are picking just 100. Now that is what sampling. Okay. So we are taking a sample from the population and we are calculating sample data and we are estimating or we are understanding population's information. Okay. So that's about sampling and sampling techniques. Okay. Now we will move forward more than that one and we can make sure to understand other concept like which I explained estimation, point-based estimation and interval estimation and testing. So these are the rest of our topics in the in this module. So with that concept, we'll close this module and we'll enter into next module and we'll make sure to understand covered next module topics in the other session. So that's the only rest of the things and I'm not entered into notebook, but we can make sure to understand. But while picking up anything, so visualization is also matter. So this is for help material to understand further and if you want to learn further so that you can move forward. Okay. So that's about total session and we'll continue with the next session with the same module. Maybe in the next 1 or 2 session, we'll close this 6th module and we'll enter with the 7th module, the next step forward. Okay. So that's about and thank you very much and thanks for watching all these sessions. So we'll meet in next session.